Orekoya Olusegun, Physics, Mathematics Fundamentals. The topic of our today is on circular motion under simple harmonic motion. Consider a body of mass m moving around a circle of radius r. There is a change in the angle and there is a change in the position of the particle along the circumference of that circle. Agree that this particle is moving with constant velocity v. When the body moves an infinitesimal distance, we have velocity plus change in velocity in that instance. Now, let us assume that this sector is an infinitesimal least small sector. This sector is approximately assumed to be a right angle triangle. Now, sine of that small angle called infinitesimal angle is given as opposite over what? Hypotenuse. Therefore, sine d theta is equal to dc over r. By cross multiplying r, we have r d theta is equal to dc. Because d theta is an infinitesimally small value, sine d theta is approximately taken to be d theta. Now, dividing both sides of the equation by the time elapsed, I mean the time the particle leave point P1 to point P2, we have r d theta over dc is equal to dc over dt, and the c over dt is equivalent to the linear velocity. And then change in angle over change in time is taken to the angular velocity. Therefore, our linear velocity is equivalent to the radius of the circle times angular velocity, where the following parameter hold, I mean the units, the parameters are the units that we can see here. Now, because we are considering infinitesimal change, we can take the vector diagram for the velocity, and we have this diagram from this initial diagram. Now, we assume that this velocity diagram also is a right angle triangle. Sine d theta is equal to the v over v. Now, when we cross multiply, we have the v d theta is equal to the v. Dividing both sides by the theta, change in time, we have the v over dt, which is equivalent to acceleration. And then change in angle over change in time is taken as angular velocity. Therefore, linear acceleration is equivalent to linear velocity times angular velocity. And we know before in our initial discussion that velocity is given as angular velocity, linear velocity is given as angular velocity times radius of the circle. Therefore, linear acceleration is given as angular velocity square times radius of the circle. Now, as the body is moving around this circle, there are two sets of forces acting. The force that is trying to make the body to move towards the center of the circle, and that force is known as the centripetal force. And the force trying to take the body away from the center of the circle, and that force is called centrifugal force. For either of the forces, we know from the Newton first law that force is mass times acceleration, and we have established before that our acceleration can be expressed in these two formats. By substitution, we have these arrangements accordingly. Therefore, our centripetal force or centrifugal force is known as mv squared over r, where force is measured in Newton and mass in kilogram. Note, linear acceleration is given as change in linear velocity per change in time,